This is the sixth video in SPSS for Beginners from the RStats Institute at Missouri State University. In this video, I'm going to show you how to compare two means from two measurements of the same sample. And this is called a within subjects design, a repeated measures design, or a paired samples design. When we compare two related means with SPSS, we use a paired samples t-test. So as before, we will use the data set that we created in the first video. So for this research project, we have a single sample that we have measured twice. Now you will often see this as a before and after design. You measure a group of people, then you give them a treatment, and then you measure them again a second time. If their scores on the post-test are higher than on the pre-test, you know that the treatment had an effect. Another time that we will have paired measures is when we have two measurements of the same group. In our data set, we measure the same people for both their height and their weight. Each person has a pair of measures. Now, of course, there is a fundamental flaw in this example because height is measured in inches and weight is measured in pounds. So I'm comparing two completely different measurement scales. A much better example would be to have a before weight and then put people on a calorie-restricted diet and then 6 weeks later measure them again to see if they've lost weight. However, in order to show you how to conduct this type of test in SPSS, I'm going to go with this rather silly example because these are the only two scale variables that I have. And we're going to use that paired samples t-test, which means we need two scale variables. So go to Analyze, Compare Means, Paired Samples t-test. Move over the variables that you want to compare. We want to compare height to weight, our two scale level variables. And when you're ready, click OK. The first table contains descriptive statistics for each variable. It has the mean, the sample size, the standard deviation, and the standard error of the mean for each variable. And below that, in the second table, we see the correlation coefficient between the two variables. We do not really need this output right now, but you will use the correlation coefficient later when we calculate the effect size. This third table has our inferential statistics. This is what we want to look at right now. So on the far right, we see the t-value, the degrees of freedom, and the p-value that corresponds to a t-score of 17.4 with 9 degrees of freedom. So as before, we want to know, are these means statistically significantly different? And we can answer that question in three ways. First, is the t-value greater than a critical value that we look up on students' t-table? With 9 degrees of freedom, I looked up that critical value. It was 2.262. This t-value of 17.4 is much larger than 2.262. And I'll tell you more about that negative sign here in a minute. So second, is the p-value less than 0.05? Our p-value is 0.000, which is way less than 0.05. Third, does the 95% confidence interval cross 0? It does not. Both the upper and lower values are negative, so they are on the same side of 0. Therefore, we conclude that these means are statistically significantly different. But as I told you, that's really not particularly surprising because we are comparing inches and pounds. So let me say something more about that confidence interval. Like, what is that? A confidence interval is a range in which the mean difference is likely to fall 95% of the time. You see, the mean difference of negative 67.2 is very precise, but it's also very likely to be wrong. If we drew another sample and tested it, most likely the mean difference would be slightly different than negative 67.2. Now, on the other hand, if I repeated this study 100 times, 95% of the time, the mean difference would be between negative 75.9 and negative 58.4. So the mean is precise, but wrong. The confidence interval is much more certain, but also less precise. However, with good measurements and low variability, we can get both the mean and the confidence intervals as accurate as possible. I also want to point out something about that t-value. Notice that the t is negative. All that means is that the second group had a higher mean than the first group. You interpret a positive t-value exactly the same way as you interpret a negative t-value. Let me show you. Go to Analyze, Compare Means, Paired Samples t-test. See that we have a space to do a second t-test? Let's move over the height and weight variables, but this time in the opposite order. And click OK. When we examine the output, we see two t-tests. Notice that all of the output is exactly the same, except in places where it's just reversed, such as with this confidence interval. In one case, the t-value is negative. In the other case, it's positive. So basically, you don't need to focus on whether the sign is positive or negative because the sign simply tells us which group was entered first or second. You should look at the actual means when you interpret these findings. And that is how we do a paired samples t-test in SPSS. When you are ready to do your paired samples t-test for real, check out these other videos from RStats Institute that will teach you more about statistical theory, setting up the test, interpreting the results, and writing up your findings in APA style.